Hi friends, myself Syed Abbasmali and my friend Prashant Takamalla will going to discuss today topic name IEEE 802.11 wireless local area network implemented on software defined radio with hybrid programmable architecture. Coming to agenda, we're gonna discuss about introduction part. Next one is design of SDR prototype. Next is software architecture and then experimental evaluation and last part is conclusion. Coming to introduction. This paper describes a prototype software-defined radio SDR transceiver and distributed and heterogeneous hybrid programmable architecture. It consists of CPU, central processing unit, DSP, digital signal processing, and pre-port processors, and support both personal handy phone systems. It also supports system switching between PHS and WLAN. WLAN is nothing but wireless local area network and over-the-air OTA software downloading. In the mobile communication field, many kinds of second generation. Second generation is the old generation mobile telecommunication technology. Now, right now we are using such as systems such as interim standard IS54, IS136, and IS95, and GSM and PDCs. In addition to these are the public mobile services. In addition to these, many private systems such as IEEE 802.11 wireless local area network and Bluetooth have become popular nowadays since there are so many interested applications in wireless local area network are applicable, but we are using hotspot nowadays very much. Under current approach, users must buy a dedicated wireless terminal for each system and operators must prepare a dedicated wireless base station for each system because these systems have their own specifications such as frequency, modulation, and coding scheme and communication protocol. SDR can change its radio functions by swapping software instead of replacing hardware, and this is the best solution nowadays. Coming to the this is basic diagram of prototype, block diagram of prototype. Here you can see external IF. IF is nothing but intermediate frequency, DSP, PPP, ADC or DSC, and multiband RF, IF, and CPU. This figure shows like it's a reconfigurable portion has a hybrid programmable architecture that combines one CPU. You're gonna see here DSP. There are 4 DSPs and PPPs. There are 3 PPPs inside it. And it has 3 independent RF, IF. RF means radio frequency, IF means intermediate frequency branches for the future adoption of simultaneous multimode operation or smart antennas. Here you're gonna see 64-bit Warsaw modulate Eurocard VME bus which connects the CPU, DSP and external interface modules. And the DSP connects to the PPP via a mezzanine IF. The CPU is a 400 MHz power PC with a real-time operating system and hard disk drive and a man-machine interface MMI device for user operation are connected to CPU via local and expansion buses. The DSP module is a general-purpose DSP board consisting of 4 fixed-point arithmetic chips, each with a 200 MHz clock and a 1600 million instructions per second (MIPS). Maximum operation power is this. For PHS operation, the external IF module provides an integrated service digital network ISDN service in cell station platform and voice and bearer service in personal station platform. This is the only difference between the CS and PS platforms. For wireless local area network operation, the CPU module provides an Ethernet IFE in both the access point and the station platforms. Next slide is design of the SDR prototype. This paper is organized as such as in first section we're gonna describe about the basic design of the prototype. Next it comes like we're gonna explain the software architecture of the prototype and the conclusion. First one is the design of the SDR prototype, where in that I want to discuss you about prototyping philosophy. Here the signal process needed for wireless communication have a variety of properties. Examples like coding schemes such as forward error correction FEC, interleaving, and scrambling need bit manipulation, while modulation or demodulation schemes demand symbol processing and layer 2 L2 processing needs frame handling. Our prototyping aim was not to create a fully commercial hybrid programmable architecture, but in addition to it, we have to identify the problems with this architecture and the direction for ideal architecture of SDR terminals. Next to it is composition of the prototype. In this prototype, it consists of 3 stages. First one is radio frequency RF, intermediate frequency IF, and baseband stages, where previously we discussed these stages in the circuit block diagram. The RF-IF stages consist of multiplan analog circuits. Analog A to D conversion is performed at the IF. The digital IF and BB stages consist of just programmable devices. This is the normal diagram of how the CPU, external IF, DSP, PPR connector interlinked with each other, and this is the control display. And the last one is the implemented radio system. Here we just in table 1 and table 2 we just compare between PHS and wireless local area network modes. In first table we just describes how RF is varies in PHS and WLAN mode. RF is in PHS mode it takes 1.9 GHz, in wireless mode it takes 2.45. Access protocol is TDMA here and CSMA in wireless. Coming to modulation scheme, in PHS mode it uses shift 5/4 shift QPSK, but in wireless it goes with VPSK or QPSK. And data rate is 32, while coming to error rate is 384 in PHS, but in wireless it's 11 MCPS and 1 Mbps. All omitted function is just to mobile the management authentic building in PHS mode. When coming to wireless, here power management. In the second table, we are going to discuss about CPU, DSP and PPP in various PHS wireless mode. While coming to CPU, in PHS mode, it can control call. And in wireless mode, it describes about MAC. About DSP, in PHS mode, it goes with modulation, demodulation, coding or decoding. In wireless mode, it goes with spreading. PPP is channel filtering in PHS mode and channel filtering despreading in wireless mode. Coming to next, my friend Prashant gonna discuss about software architecture.
Hi, good evening. This is Prashant. Before me, my friend discussed about the introduction and design of the SDR prototype. Now, I want to tell about what is software architecture. Software architecture, the hybrid programmable architecture is a CPU and DSP and PPS enables more flexible task assignment, but the arrangement adapted seriously and influence the system performance. This section will also describe the architecture of software assignment to the each processor in WLAN mode and the SIFS issue, which is the most difficult problem when implementing IEEE 802.11 WLAN on this architecture. There is two kinds in this software architecture. We can see the two different categories. First is a function assignment of communication task. Here we can see the two main modules like CPU and DSP. In two main modules, in case of CPU, we have two different kinds like application task and kernel task. In case of application task, we can see the SDR controller and MAC protocol handler and LLC Ethernet bridge. In case of kernel, we can see the VxWorks kernel and Ethernet driver and DSP driver. The CPU interlink with DSP. Like DSP driver interlink with the DSP monitor. In case of DSP, we can see the PLCP task and modulation and demodulation task and DSP monitor. Then we can say that like system performance depends on to a large extent on how the critical functions such as modulation and demodulation and the protocol sequence processing are assigned to different processors. This above figure it shows the software configuration of the prototype in WLAN mode. Like we use it here like VxWorks because the WLAN protocol has far stricter requirements in terms of the interrupt response time than PHS, and this real-time OS also allowed to optimization of the function assignment. Our previous SDR prototype used to Solaris and was unable to achieve the adequate inter-process communication. So the VxWorks offers significantly shorter interrupt times and allows finer allocation of tasks. Future works include optimizing the SDR design by examining the other factors that influence the hardware and both with software configurations and such as interrupt response time and content switching, interval and bus bandwidth and the control shared memories. In implementing the various IEEE 802.11 functions on the prototype, we assume that the max sublayer functions would be executed on the CPU, while the PHY functions such as modulation and demodulation would be processed by the DSPs. So, here the PPP used to perform the high-speed process that cannot be run on the CPU or DSPs. The second one is resolving the SIFS issues. SIFS is nothing but is a short interframe space, and the analysis of PHY and MAC process of IEEE 802.11 shows that the SIFS value imposes the most severe requirements in terms of response time, and SIFS in the DCF mode represent the time available for completing the high priority operations such as acknowledgement response to the MAC data unit like reception and the CTS response to the RTS reception. So you can see this diagram. It shows the delay times elements of SIF process. We can see the three categories like PPP and DSP and CPU, which I said earlier. Here the symbols can be processed by using of SIF processing time. We have to process the PPDU first symbol to PPDU last symbol. In case of PPDU first symbol, the delay was occurred by a DSP modulation process. In case of PPDU last symbol, the delay was occurred due to the DSP modulation process. Every time, in case of in this, the function assignment for the CPU and DSP is ideal. So the delay elements of the SIF process which can be represented in the diagram. It is an example for the sequence from the PHY convergence protocol like PLCP and PDU, PPDU, reception to the acknowledgement response. Like SIFS is the time from the reception of the last PPDU symbol to the transmission of the first symbol response to the PPDU. The period from PPDU reception in the RA part to acknowledgement to the PPDU. So the transmission is defined as SIFS in this paper. So the delay response process is described in the timeline and it can be decreased to some extent by using parallel processing. To complete the testing of the prototype in the shortest period of time, we restricted ourselves to using only commercial hardware. Okay. The above figure represents the PHY characteristic, both like transmission spectrum is above 1 and the correlation output is below 1. The output signal of the PPU were measured to evaluate the basic PHY performance for WLAN mode. So the spectrum at the output of the PPU transmitter in WLAN mode as shown in the figure. The below figure shows the correlation output of the PPP of receiver in WLAN mode. Peaks were monitored every 22 samples for 10 MHz, which represents twice the oversampled data. It's an experimental evaluation like max sublayer performance, and the measurement of the MAC layer performance depends on two categories like one-to-one communication and one-to-two communication as shown in the figure. In case of one-to-one communication, packets were generated and received by the connecting LAN and analyzers via Ethernet to SDR sets, and Ethernet frames were used. At the SDR transmission set, the Ethernet frames received from the Ethernet IF were converted into IEEE 802 frames without a check frame sequence and then transmitted to DSPs via the VME bus. PLCP frames were first generated by adding FCS and PLCP header and PLCP preamble in the DSP and then writing them into the first in first out buffer in the DSP board. And the conclusion is that the SDR that has distributed and heterogeneous hybrid programmable architecture and is intended to realize IEEE 802.11 WLAN operation. This is my references, and thank you for giving this